Okay, so we'll continue from the last week section. So we were discussing about several C programs, and these programs intend to improve your skills on C programming. So last time we stopped at that while loop. We wrote that while loop. Okay, so we'll continue from that point onwards. So for the today's session, uh, so in the first part, so you are asked to compute the factorial of a user input integer less than 35 using the concept of recursive functions with possible error handling. So why this number is less than 35? Because the factorial of a number is a very large number. So when it is more than 35, the size of the factorial becomes uh, greater than the maximum allowable size for a integer. That means, so we have to use a long integer here, 8 bytes. So it will exceed 8 bytes and erroneous result will return. So the factorial calculation should be less than 35. And also it cannot be go beyond, that means less than 0. It cannot go become less than 0 factorial of a number. So we have to check uh, those conditions. So those are the errors which can occur. So we have to make sure that the number is not more than 35 and less than 0, right? And about the recursive function, so a recursive function is is the same function being called inside that function's declaration. That means if you write a function, if that same function is called inside that function, then it is called a recursive function. So we have to write this program, the factorial of a number, as a recursive function, right? So we will see how we can do that in C, and we compile using the GCC. Okay, so first I have to change directory into my working directory is this one. So I'm going to edit this C file to write my program. So just to remind you what we discussed last week, to refresh your knowledge, I'll do this program starting from scratch, right? So first you have to include, so as we are using the user input and output, so we have to use stdio.h header file. And any program should have the main function. So its return type is integer main, and it has no arguments. So this is the minimum function. So if I refresh your knowledge on how to compile any C program, so we have to use the GCC compiler, and we have to type in the our C file name. Then we have to create an object file of our desired name. So this is the name of the object file, and this is the name of the C script that we write. So once you give this command, it will be compiled into an executable file. If it has any syntax errors, it will give any syntax errors, and we can write, that means execute this object file by saying that in this directory execute this file. So this is the minimum program, so nothing happens. So what you want from this is to first get the user input. So for that, if you can remember, we use a function. First we have to tell the user to input. We'll say enter an integer to the user first. We'll prompt from the user. Then we have to get and store that integer. But as the factorial of a number is very large, so we have to use the highest possible size. So what we'll do is, so we'll use the unsigned version. Unsigned long integer. So I use unsigned is, so in signed integers, one bit is used to store the sign of the number, that is either positive or negative. So if you declare, so as the factorial of a number cannot be negative, so we can make use of that bit also. So we can use it as unsigned, right? So then there will be this is long. This will be a long. Long means 8 bytes. 8 bytes, and full 8 bytes is used as it is unsigned, right? So we have to get that from user. So if you can remember, the format specifier for a long is L, and for integer it was D, but for unsigned integer it was U, LU. Now it is not LD, it is LU. So we discussed these formative specifiers last week, right? And now here we have to pass the address of the number, and then we have to return the output using another printf function, and we'll call the function inside this printf factorial is, and here we have to get the output from the function. And here we have to pass the function. So I'll name the function as factorial and pass the address of this number. So have to declare the function first. So its return type must be definitely unsigned long integer. The name of the function is factorial, and the argument that we pass here is an address of unsigned long integer, so it should be pointer type. Pointer of unsigned long integer, any number. Right, so first we have to do the satisfy some conditions. So first we have to check whether this number, so we have to check not, so this is a pointer, so we have to check the value of that number. So we say that value by this operation star number. If number is less than 0, then we have to print this command. Factorial cannot be less than 0. And the most important thing is when if the user enter a number less than 0, this command must be issued, and then the program should exit without coming here. So without coming here, the program should exit, right? So for that, so for terminating a given process, so I'll teach that one in detail in when we are discussing about the processes and threads. So to exit or to terminate a given process, there is a function known as exit. Exit. So we have to pass the argument as 0. So that this means terminate the process. And this exit function is not defined in this studio library. It is defined in a library known as standard library. stdlib.h. Right, so what will happen if it is less than 0, it will print this and terminate the whole main program. So main program is a process, and this function is called, so otherwise we could have used break. So if we use the break, it will only return out of this factorial function, and it will come here, but it will not terminate the process. But if it is less than 0, this main program should exit. And the other thing is if it is greater than 35. Greater than or equal to 35. Then the number is too large. To save time, I will just copy paste this one. And otherwise, and also there is another condition, if it is 0. Otherwise, if it is 0, we have defined the factorial as 1. So here there is this is not assignment of A, it is equal. So we have to use double equal marks. So if it is 0, we have to do what? We have to, so this should return something. The returning type must be this one. So we have to return 1. Otherwise, then we have to call the recursive function. Else, we have to return. First, we calculate that sine. I'll just declare a temporary variable and assign the value to this one. So what is the value? So factorial is, so if it is factorial n, it is n times n minus 1 times n minus 2 times until it is 0. So we have to call, so it is, this is number, so value of number n times factorial of that number minus 1. So we have to call this function again here. That is why it is called a recursive. Factorial this value minus 1. Then this will be called again recursively, and these conditions will be checked. According to this number minus 1 value, it will return. And the return value will be coming here and it will be calculated. And so we have to return this one also. Calculate and then return this one. Right, so that is the function. So we'll compile and see whether there are any compile errors and then run the program. Okay, there are some warnings. So there is misspelling in line 10. Okay, we'll compile again and see. Uh, 49. Oh, 49. So for me there seems to be fine, but this is giving some warnings. So we have to check those things. First, it says that in line 50, passing of one argument, factorial makes pointer from integer without a cast. Maybe I have declared this one in the other. Maybe we will use long unsigned integer. It is still there. Maybe we'll calculate this one in a separate one. That may be the issue. Uh, so it is number minus 1. Then we'll get that and return number times. Here also. So you have to be careful in writing these things, pointers. Otherwise, it will, that may be the issue. So here, the number pointer means value of this number. Otherwise, if you take star minus 1, then it will be number minus 1 value. So it will give a different meaning. So you have to be careful in writing these things, right? Otherwise, it will give unnecessary errors in your program. So you have to say that this pointer belongs to this value only, right? So I have to get that one, then multiply with factorial. I think it's okay now. For to be safe, we'll keep a bracket here also. So this star is not for a pointer; it is for multiplication. So this star is to indicate the value of this pointer, that is this number. Here, this is value and minus 1. Okay, now we. Okay, it is giving a warning still. So, but we'll try and run the program. It is 0. Okay, 1. Maybe you can answer. Uh, But is it correct if you get the factorial of it? Because the number is a point, no? Ah, because this show, yes, yes, yes. So this should be a pointer, no? So the argument of the factorial must also be a pointer. Argument of the factorial must also be a pointer. So this is a value. This is a value, and so this should be a pointer. So to be a pointer, we'll get this on address. Then it will work. So we should give the address of this one because this argument is pointer type. No? So this argument is pointer type. So you calculate temp equal this number minus 1, right? But we have to pass the address because this is a pointer and this is should work. Okay. Factorial is 2. It is if we give minus number. So if we give a minus number, too large. So because this is if we even if we give a minus number, it will not consider it as minus because this is unsigned. No? So we can remove this one. So even if you give a minus number, it will not get this one as a minus. It will get it as a plus one. So what we have to do is, so this is long, but we'll make this one sign. We'll make this one sign, right? Then you will enter, even you can enter a negative number, right? So we'll make this a sign LD. And as the output, we'll get an unsigned value, long unsigned. So the output is long unsigned, but we'll give an input, a signed input. We'll give a signed input. And so here also it should be signed because what we give as inputs is sign. So you have to compile it first. Yeah, now it is okay. Factorial can be less than 0. Otherwise, if you input, even if you input minus 1 for an unsigned integer, then it will store as a positive number. Then there is no point in checking the minus logic there. So we will input a signed one, but it will check and return an unsigned. That is unsigned, you can get the maximum value. Right? Okay. So we will check. Yeah, even if it's a big value, it is given. And yeah, so that's how you do this. So we have to be careful in dealing with pointers, right? So here, what I had done there was I had not passed the address of this one. Okay. cannot get this screen. Okay, so that question is over now. So now we'll go for the next one. So I give you this one as a homework. So this is to find the minimum of user input 10 numbers using arrays and loops without using functions. That means you have to write inside the main program without using functions, right? So I'll do this one as an example. So in here, we have to find the maximum of user input 10 numbers by passing of array inside the function. So in this one, we will see how an array can be passed. And we have to find the maximum of user input 10 numbers. Okay, I'll just edit the same program just like I said last week. So you can create a separate program for this. Okay, so what? So I'll just edit this one. So first thing is to get user input 10 numbers. So a bad way of writing this is scanning the user input 10 times and writing whole of those 10 lines here. And the better way of doing that one is writing it inside a loop, getting the input inside a loop, right? So we can, so first we should declare an array. So the user input can be any type. So I'll say that it has a double. I'll say the inputs. So these are the inputs and we have to store it in an array. So we have to get 10 inputs. So this is the way of declaring an array. So it will allocate 10 consecutive locations for this variable type double. It will allocate 10 consecutive locations, right? So we'll scan the user input by using an array. So I'll write an for loop. You can even write a while loop, just like I explained last year. So I'll initialize an integer to 0 and until it is less than 10, that means it will run from 0 to 9. And so we will say that enter number. So we have to get 10 numbers now. Enter number. I. So I, instead of that one, we can pass. So this is double L long float. And what will be the value here? Sorry, so this is not long float. So we have, this is index. So it is integer. Integer D. And it is I. So when it is printing, it will say enter number 0, enter number 1, likewise. Then we have to scan the user input, and so it will be stored in here. So this will be long float, a double type variable, and it will be stored in the corresponding array location, right? It should be stored in the corresponding array locations. So this, the name of the array is nothing but the address of the array's first element. So name of the array is array's address of the first element. So if you say inputs, so that means it is the address of inputs, this square bracket 0. That means if so, to scan we have to pass the address. So I will say, so it is when it is I, that means I equals 0, it is inputs, and when I equal 1, it will be inputs plus 1. So likewise I can say it is inputs plus I. This is the address of the ith element of the array. This is address of ith element of array. Right? So another way of telling this one is like this. It is equivalent to address of inputs I. So if you say inputs I, that means this is value at ith location of the array, and by this sign you say it is not the value, but it is the address of this location. It is the same like this. So inputs is the address of the first memory location. When you increment by I, then you get the address of ith element. Right? So this basic thing you have to keep in mind in dealing with arrays. So just that one. So just 2 lines. So by using a loop, you can iterate, and so it will say enter number 0, then it will store it in 0th location of the array. Then enter number 1, then it will store at first location of the array. Likewise, it will iterate and store all the numbers. Then we should write the maximum function to get the maximum. So I'll say maximum and so to get the maximum we have to pass this array inside this function. So in order to pass the array you have to use the address of the first element. So what is the address of the first element? It is inputs, right? So it is an address, so it is, then it will be a, this is of type double, so it will be a double pointer, right? So we have to pass the address of the first element of the array, that is inputs. So if you will understand when I declare the function more. So the return type must be double, and the name of the function is maximum, and what we are doing is we are passing the address of the first element of the array. That is how you pass an array inside a function. So I'll say double pointer. Double pointer. Right, so what we have to do is we have to find the maximum. So how we are going to do that one? We have to check each and every element with the other element. We get the first element and compare, and if it is the maximum, we make, if the value 1 is less than the other one, then we make value 2 the maximum. Then we take the second and third element then compare, we make the maximum the higher one, right? So in the first place, we'll declare a variable known as max and assign it to the value at this location. So this is the first pointer of the array. So we get the value at this location. We get the value at this location. That is what this means. And then we keep on comparing. And we will not write 10 lines, but we will do it in a loop. So to refresh on while loops, I'll use a while loop. So I'll just declare an integer and initialize it to 0. While I is less than 10, there are 10 elements. So what I will do is compare the ith element with the maximum. So I have initialized it to the first element. I have initialized it to the first element. So always I have to compare it with the next element. So I will here, as it is the first element, I will make this 1. So if what the value at, so then the ith location of this array. So this is an array pointer. So we have to get the value at ith location of the array. Value at values plus I. If the value at the ith location of the array is greater than max, it means this value, then what we will do? We will make the maximum this value. Then max is assigned this value, values plus I. Then max is assigned this one. Otherwise, we do nothing. We keep the maximum the same value. So in while loop, we have to increment the loop counter every time. Plus plus. And at the end of this while loop, we have to return the max. Right? So this is how you pass an array inside a function. So we'll see whether there are any errors. Yeah, this is from the previous program, so this should be a long float. Right. We'll see whether it is working. So you have to keep on, so as I wrote, it is there on a loop. So we'll just enter some numbers. So the maximum value that I entered is this one. So it returned the maximum value. So the program is fine. So you must know how to pass the array inside a function. So using this example, you can understand. So what we pass is the pass by reference. The method is pass by reference. When we pass an array inside the function, we have to pass the address of the first element. As you can see here, we are passing the array. So address of the first element is passed. So it will be a pointer type, right? It will be a pointer type, and it will come here. And those things after that done, you can increment the address as you want, like this. You can increment the address. When you increment the address, you get the other values. When you increment the address and get the value, you get the other values. And you can compare and get the maximum. And there is an alternative method of pass, let me think, writing this one as an array in a function is in declaration. You can write like this. Instead of saying this as a pointer, you can say this one is of array type. That means a pointer. This is a pointer to an array. You can call like this. So this says that it is a double type pointer, but not an ordinary pointer. It is an array. Okay. You can see there are no compile errors. And if you want to check again the program, yes, still the program is same. So this is another notation of passing an array inside a function. So it says that it is a double type pointer, but it is an array pointer, not an ordinary pointer. It is an array pointer. Just the same notation is different, but the same thing is, otherwise you can say double star values. Right, so that example was done to show you how an array can be passed inside a function, and addresses of array, how to access different elements, how to pass different address. So the important thing that you learned was the name of the array contains the first element address, right? You can go to other addresses by indexing that first address. Right. So you can do this one as homework to get practice. And we'll move on to the next section, which is the last part of this C programming. So in the next example, we are asked to arrange user input 10 numbers in ascending order with the knowledge of arrays, loops, pass by reference functions, and pointers using bubble sort algorithm. So in the third semester of you must have studied about the bubble sort algorithm, and you must have even implemented this one. So this is just a refreshing of your knowledge, right? So if you remember the bubble sort algorithm, it will keep on comparing each and every element with of the array with one element. So it first takes the first element, then compare with the remaining 9 elements, and at the end it will select the highest one or minimum one and arrange that. Then it is finished. Then it will go to the second element, then compare with the remaining 8 elements and find and sort that element. Then it will go to the third one, and likewise it will continue, right? So in here also we will use passing of array, right? We'll get more experience on passing of array inside a function. So the input is same, right? So input is same. We can input the numbers like this. So instead of maximum, I will say uh, the function name, I'll call it as bubble sort. And this function will not return anything, or maybe we can return the array. So we'll return the array, right? So we'll use a double point. So the return type, I'll call it, use it as a double point, and we'll return the array. We'll pass the array, and then we'll return the array. And yes, we pass the array here, and we return the array here. Okay. So we'll modify that this function. Bubble sort, right? So even if you declare this one, you can, as it is the notation is equivalent, you can say this one as a pointer, not difference. Right. So in bubble sort, we if this is greater than, if an element is greater than, we do something known as swapping. That means we exchange those two elements. So we will write a function for swapping, and it will not return anything. Void swap. So the inputs are two pointers. I'll say x and y. So we have two pointers, x and y. We want to change the value of these two ones. That's why that's what we call swap. That means we want to make x y, we want to make y x. So for that one, we have to create a temporary variable, and assign the value of one. We'll say x. We assign the value of x to this one. Then we change x. We change, assign the value of x as value of y. We make x the value of y. Then x is not longer x, now x becomes y. Then for the value of y, you assign 10. You make y 10. And you return nothing. Right? So that is the sub function. So we will use that sub function here inside this one. So in bubble sort, what you do is, so you get the one element and compare with other elements. Then you take the second and compare with others. So when you think of that, then for your mind it should come that you have to use two loops. One loop inside another loop. So the inner loop will become the comparing second element, and the first loop will be the index, will carry the index of the first element. The inner loop will carry the index of the second element, which is compare. Right? You will understand when I write this one. So for the outer loop, I will use a for loop. So its index, a loop index will run from 0 to 9. And the second element which will be compared. So what we do is we take the 0th element and compare with the ninth element. Then 8th element will be compared with 0th element. 7th element will be compared with 0 element. Likewise. So I will write inside loop as a while loop. So I'll initialize j, sorry, to 9 because the maximum index is 9. So I'll tell that while, so the inner loop will run until j is greater than I, because when j is equal to I, then there is no comparison. So while j is greater than I, what we have to do is now we have to compare. Compare what? We have to compare this array's ith element with jth element. So we have to arrange in ascending order. So we have to check if if value at values. Values means this array's first element. What we pass here, array's first element plus I. So this is what the location of the ith element of the array and its value. If it is greater than the value at jth element, then we should search to make this one in ascending order. If this is true, then we have to interchange the values at ith and jth locations. We have to interchange the values at ith and jth locations. That is the logic. So we have to call that swap function. So for swap function, we have to pass the address of the values. So we have to pass swap address of these two, values plus I, comma values plus j. So this loop will continue to run. So we have to decrement the loop count. So j will run from 9 to until I plus 1. So at the end of this loop, it will return, and then I will become 1. Then it will again run from 9 to 2. Then I will become 3. Then it will run from 9 to 4. Likewise, it will keep on continuing and comparing, and the values will be swapped. Then at last, we should return this value. Return values. So because values is a pointer, this is a double pointer. Return values. So in here we will write a function to print all the elements of the array. Not a function, actually a while loop, a loop. whatever for or while loop. So here we get the input. Now we print the output. So before that we have to call this function. I'll say double printer so it will return this function bubble sort, this one. Also you have to pass the first element of the array. Then it will sort the array and return here. Then what you have to do is you have to print each element. We print it as, so the type must be, this is double long float, and here we'll print a comma, and this should be, so this contains pt, so pt plus I. If it is 0, it will print the first element. If it is 1, it will print the second element. Likewise, it will print. Yes, I have missed the pointer here. This should be value. And more is printf. Yes. So in here, when we are printing, so we have to print the value at that particular array position. So to tell it is a value, we have to tell it as star. Otherwise, an alternative way of writing the same thing is what? pt I. The method which is usually known to you. Is also okay. Morris 29. Here you have to use semicolon. And here I have missed. Now okay. So I just enter some numbers. So it arrange the numbers in ascending order. You can see the numbers are in ascending order. It is better if you write something like here the numbers in ascending order is, and remove this comma. Okay, that thing you can do, so you can imagine. So I will not go into write that one, and I think the program is clear to you. So here also we used passing of an array inside the function and returning a value from an array. So when you return an array, you can return not as a value type but a pointer. So you can even pass an array as an argument, as a pointer, or in other terms as an address, and you can return an array as a pointer, and you can increment the pointer, that address, and get the values of the arrays like this. Right. So that's what I wanted to highlight here. So that's all about arrays, functions, pass by reference, pass by value, everything. So that concludes that section. Right. I hope the section is clear. So if you have any doubts regarding pass by array, pass by reference, you can ask. Okay. So now we'll move on to, I mean, still the C programming, but a different concept. You may even know these things. So I will give some more exercise for you to do in home. So do this one as a homework. So this is also again writing to and from an array. So I will not repeat this exercise here. So I'll upload this one so you can test this program on your own. Right. So again, the same concepts used here again, right? Ordering. Okay, so now we'll move on to this question. So in here, we are asked to create a structure and a union type to store the weight, age, and height of a person. Obtain the inputs from the user and store each instance of person, structure, and union. Then display the stored value in structure and union on the console. So now we have moved on to a different area. So about structures and unions. So when it comes to structure and union, so they both store different data types in its either structure or unions data type. So they are container data types. They are called container data types. They store different data types, right? And the way of accessing the members, so the data types inside either structure or union is known as members of that structure or union. So the way of accessing those members is similar. So you use the dot operation to access the members of a structure or a union. So there is another way of accessing a member of a structure. I tell you when with this example, when I do this example. And the difference between the structure and union is the structure can initialize all of its members and it has memory locations for each and every member of the structure. But in union, there is only one memory location and the size of that memory location is equal to the highest data type of the of one of the members of the structure. For example, if sorry, not the structure, union. if the union has a character data type and integer data type, then the size of the union will be of size integer, because integer takes 4 bytes, character takes 1 byte. And only one item can be initialized in the memory of the union. If the union has, for example, say 3 different data types, but it can have 3 different data types, but only one of them can contain a value at a time. So a union is for efficient use of memory, not like structure. But in structure, there will be different memory locations which contain different values of that members of that structure data type. That is the difference between structure and union. Union can efficiently use memory, but it cannot store all instances of its members at the same time. So in this example, we'll demonstrate that concept between the difference between structure and union using this example. So first, so this asks to create a structure and union called a person to store its weight, age and height. Weight, age and height. So first we'll create a structure and a union. So the way of creating a structure and union is by using the keyword for structures, struct. Struct, then name of the structure. I'll say person, so as this is a person type, person struct, person structure. And what are the members? Weight, age and height. Weight, so you have to declare the data type first, double weight, this is how a structure is declared. So the declaration of union is nothing much different, only the keyword is different. Only the keyword is different. So instead of struct, you can use union. And the same members are there. And you can use the same names because these are local. These variables are local to this union and these variables are local to this structure. So you can reuse these same names. This weight is different to this weight. These have different local scope. Right, so that is the declaration. So then we should write a function to initialize this structure and union. And I'll name it as struct initialize. And the return type, so this person struct now is a data type. Now the data type struct person struct is another data type, but this is a user declared data type, not a data type like integer, double or character or other standard data types. So now this is, you can use it as a data type. So data type, that means return type of a function. You can use it as a return type of a function. So I'll say that I'm going to return struct. This is a because data type. struct person struct, and the name of function is struct initialize. And as the member, you have to use again a structure. Okay, not the structure, we'll use these values. Well, okay, we'll use a pointer. Wait. So the initialization of union is also same, but we'll use, we have to use the union type. Union, so this is the return type. Return type is union, person union. Person union struct, sorry, union initialize. Union initialize. So how we will do the initialization, now we will see. So this is the declaration of the function, and so now we will initialize it. So I will delete the previously declared functions and copy paste it here, and now I will define the function. So the return type is this one. So we must create first an instance of this person struct. So how to do that? We can declare an instance. So an instance, first we must give a name of that instance. I'll say instance 1. So this will declare an instance of this structure of this person struct type. That means it will be create an empty structure of this type where it has weight, age and height as members of the structure. Then what we will do is we will initialize this empty structure, this instance of this empty structure of this person struct data type with these values. That's what we do. So we initialize. So how to initialize? We have to access the members of the structure to initialize. You can do the member accessing by using dot operator. Dot operator, hey, the name of the member is value of this one, is value of likewise this will be 1 dot value of this one. Is value of height, right? So now when we do this empty structure instance has been initialized with these values. Then at last we have to return this value. So we can return just like a normal data value. Return the value. Return this one. So the similar kind of initialization can be done for union also. The only difference is the data type is different. Unfortunately, in this gedit, the find and replace function is not there, so I have to replace all manually. Right. So now we have written two functions for instantiating both structure and union. Right, for instantiation both structure and union, now we have written two functions. And in the main function, so like before, we will get these three values. So now we will remove this loop. We'll say that it is double weight age height. And we'll get the user input like this. Enter weight first. So it is of no need these things. And then it should scan this input. And it should be stored at address of weight. It should be stored at this address, and it is long float. Okay. And similarly, you can get the other two also. And here you have to get age, and this is an integer. This should be stored in variable age. And this should be height. And again it is a long float and should be stored in this variable height. Right, now we have input the user inputs. Then we can use, we can call these two functions to initialize the structure and union and get this. So this will return the value here, so we can get that. So first, to get the structure, we have to declare. This is the data type person struct, and we will say str1 structure 1 is equal to this function struct initialize a structure, and we pass the address of these three to this function. Then it will initialize, it will create a structure and initialize it and return it here as the instance of this str1. So this is address of weight, age, age, height. Now the second one, it is a union. We have to initialize a union like that. Data type is person union. And I'll say this one is union 1. And the function name is union initialize. And same arguments can be passed for that one. Now we have initialized both union and structure. So now we will return the values. Just issue two printf commands. I'll say first we'll return the values for the structure. For the structure, first we'll return weight. Weight is the particular value for weight. Age, particular value for age. And height, the value for height. And as the argument, so you have to pass this. So as the arguments, what you have to get, this is structures weight, structures age, and structures height. So how to access the members? You have to type the structure name and the member name, and this will be str1 dot age. Right, we can issue a similar command to get the members of the union. So this is for the union. Same thing, but you have to get the values from the union. Right. I think the program is clear. So we get the user inputs, then initialize the structure and union. Then we try to get the each and every member of both the structure and union, and we will see the output. I think in this print command, so this should be LF long float. Okay, now it's okay. Right, so it gave an output. So for the structure, the weight, age, and height were written like this. So all the members of the structure you could return. But for the union, uh, you can get the age variable as 0 and both height and weight was obtained as 170. So that is because of what? So I told that when I introduced about union and structures, union has a data type, a size of, so the size of the union is the size of its highest size member. So here we have a double type variable, a normal integer type variable, and again a double type variable. So the union's maximum size is of double type, that is 8 bytes. And I told you that the union can contain only one initialization. So here you in union's initialization, we initialized. So how the union was initialized? First, I initialized, so the union is also same, I cannot go down. The first we initialize weight, then initialize age, then height. So what is stored in this union is what we entered last. The height value is stored. So that means in a union, the final initialization which we done will be stored. So if you initialize, do the initialization only one time, if you only use weight, then the union will contain this one. The other two values not will be contained. As we finally initialize this one, that value is there. And also, if it has any other member with that same size, if it has any other member with this same size, so that is also returning that value, because this size of this union, what is at the union after this initialization is a double type variable, which has value 170. So even when you write the weight, you will return this one. So for if you initialize age at last, then you will get age. For example, we will do that one. Sorry. So instead of initialization of height, I'll initialize age at last and height before for the union. Right, so we'll run this one and see now. Now what happened? There is no change in the structure. Did I compile this? Okay. The age is having 28 and the height is having 170. So because this can also be contained in the structure. So previously this age value was not there. So what we did here was we initialized this at last. We initialize this at last. So this value, so it has two members, a double type member and an integer type member. So the size is 8 bytes, and in the first 4 bytes integer is stored, right? In the first 4 bytes integer is stored, and in the last 4 bytes this double type is stored. right? So as this number is less, so it has this sign. So only one member can be there in a union type at a given time, and this has occurred because the double type, the size is higher than this one. That's why it is read in this value. Otherwise, this is the one which is actually at the actually overwritten at the last initialization, and this is from previous. And if the size of this member was larger than this one, these values will be overwritten. As the integer data type is 4 bytes, even though we write here, this data is still there. But in case if all three data types were same, then only this value will be contained. For example, I'll change this to double and show you. I have to change every instance, but and here again it will become a long float, and now the union size is 8 bytes. Now we'll see. Yeah. So what is initialized in the union is, what is lastly initialized is age. Age is the one which is initialized at last. So it is the only value which is contained in the union. But in structure, all values are there. So that is the difference between a union and a structure. So they are used for different application in operating system. It can be used for operating system programming, different application based on the application. So you will see when you do the programming part for the operating system. Right. So that is an introduction to structures and unions. So here is the last example of our C programming session. So in here you are asked to create a triangle structure by nesting 3 XY position structures. Uh, as members of the structure, you can use other structure data types. That means a structure can be nested inside a structure. As members of the structure, you can use another structure data type, right? So in here, we'll see how to do that. And what is asked is, we have to create a triangle structure by nesting 3 XY position structures. Get the user input for 3 points. That means there should be 3 points in a triangle. So XY, 3 XY coordinates we have to obtain from the user, and we have to create a function to display perimeter of this triangle. And in here, in this program, we will use how to use pointers to structures and how to access data members of the structure using pointers. In the previous program, we returned the value, This is the return type was a value type. Now we will use the pointer type in this example, right? So first we have to declare the type of structures. The first structure is the point. That means location of a point. A point is what? Just x and y coordinates. I'll say x. Point consists of x and y coordinates. Then now we will not discuss about union, only the structures. Then a triangle. And this triangle structure consists of point structures of this type. This point structures that consists of 3 point structures. So what is the data type? Data type is struct point. Struct point is a user declared data type. It can be used anywhere now to declare or initialize a variable or as return function or as argument of a function. Once you declare the data type, you can use anywhere. So now it will be used as a member of another structure. So this is the data type of that point structure. And I'll say this one as point 1. And similarly, two other points. Point 2 and point 3. So just like before, we have to initialize this point and triangle. So struct, first we will initialize the point. Point, I'll say this one as point initialize. And you have to pass two double variables as x and y. And again, now we'll declare a function to initialize the triangle. So it's data type, return type. Now we'll use the pointer data type, right? Triangle, this is the return type, but a pointer. Here also I will use a pointer. And as the arguments, what we should do, as arguments, we should give these 3 points to initialize them. So it is like it should be pointer to these 3 points. Say PT1. That's how. So to initialize the members, you need to know the address of those 3 members. Right. So now based on these 2 functions, now we will write. So for the point, we will write. I'll just copy paste this one here. And how to initialize a point. Right. So first I should declare this type of point empty point with this data type, empty point, but this time it will be a pointer type, struct point data type. I'll say it as pt pointer. This will be an empty pointer, and now I want to initialize this that with these values. What is contained in these locations. So now the structure it is a pointer. So when there is a pointer, you can't use dot operation to access a pointer, a structure pointer's members. So you have to use this operation. Minus greater than symbol says that this is a pointer to structure. As you can see, this is a struct pointer. So this is a pointer to structure. So you can access the members. What are the members? X. X is the member. And it will be assigned the value of X. Similarly, it will be assigned the value of Y. Then at last we return. So this is a pointer data type. So this pt is a pointer. So we return this one. And here what we can do is a similar thing. So how to initialize this one? So triangle has 3 point structures, right? 3 point structures. So we have to first declare this type of triangle, struct triangle pointer. Let it be called TRI, right? So how to access data members? TRI. So as this is a pointer, you have to use this operation. Its data members, first one is pt1. Point one is so we can use this point initialization to initialize the points of these ones when we get the functions. But this one, we will use this. So this is a structure to pointer. So we will assign this pointers. Actually, this value should be assigned here. Value of pt1. Pointer 2 is assigned to value of pt2. Likewise, pointer 3 is assigned to pt3. And at last we have to return TRI, which is a pointer, again compatible with this one. Right? Okay, so now the initialization of point and triangle is okay. So as given in the question, so we have to calculate the length and perimeter. So to calculate length, we have to write another function. So as the length So as the length is a double, so the return type must be double, and name of the function is length. So what will be the arguments of this function? For the as arguments, we have to pass 2 points. So the length is calculated for 2 points. So 2-point structures should be passed. Struct point star, I'll say pt1. Again another point. And now I will calculate the length. So how to calculate the length? So we have to get the x and y values of this point. So the equation is x1 minus x2 square plus y1 minus y2 square square root, and the square root is in a header library of math. So we have to include math.h. But include math.h, and here first I will get x1 minus x2 square. I'll get it as value 1. x1 minus x2 square. So how to get x1 minus x2? x1 you can get, so pt1 is a pointer, you have to use this one, pointers x, and not the this one, x1 minus x2, pt2, this is x2, and you have to get the square of this. That means multiplying this again. And similarly, you can get the next value, y1 minus y2 square. I'll call it value 2. That is 0.1 y, 0.2, this is y1 minus y2. And at last you should return value 1 and square root of sqrt is the math function to get the square root, value 1 plus value 2. Then you get the length. Then you have to calculate the perimeter. So for that time, you just create another function as perimeter, and as that one, as the argument of that one, you have to get this is so you calculate the length, right? So calculate the length. For this one, you have to get 3 points, or in other terms, as these arguments, you can pass a triangle. Struct triangle. I say TRI1. So first, you should get the first length between the first 2 points. So I'll tell it as double length 1. 1 is equal to, so we can use now this function, length, length, first two pointers to first 2 points of this triangle structure. So that is TRI1 dot, so this has PT1. This is the first point, and you have to pass the address of that. So using the address operator, you can pass the address. So length between first point and second point. This will calculate the length between first point and second point. Similarly, you have to get the length between other 2 points. This is length 2. This means first point, and I will get this one as third point. So now I use the dot operator. Why? Because this is not a pointer. This is just the triangle data type. So for values, you can access using dot operator. Length 3. This is triangle point 2 and point 3. Now 3 lengths are obtained. Then at last, so we can return length, not the average, so length 1 then plus length 3. Length 2 plus length 3. Return, we can return the perimeter like that. So now we have written all the functions necessary for this program. So just we need to call those functions here and get the result. So we have created, not yet, this is for the previous program. So this should be first, this will create a triangle structure. Struct triangle, we'll say it as TRI1. Is equal to, so we can directly call the triangle initialization function. This should be union initialize. And we can call triangle initialize. So as the triangle initialize, we should pass 3 pointers, and using this point initialize, we can initialize the 3 pointers. So I can call point initialize, and in that turn you have to pass the uh, first 2 points, and we have to get the 3 points. So I'll get the 3 points using an array. X values will be stored in 3 consecutive locations, and Y values will be located in 3 consecutive locations. So today I'll take 10 minutes, 10 to 15 minutes additional time and finish this section. Then we can start from a new section next week, right? Okay. So, and also I'll write a loop to get these 3 points from the user. Integer I equals 0, I less than 3. So it will run from I equals 0 to 2. And the first one, enter, I'll say enter x, and here I'll use the index, and here I use I. Then it will say enter x1. Then user will enter the value, and it should be stored at x plus ith location. Just like I said before, x plus I contains the address of the x plus ith location of this array. And similarly, you can get y. Enter y, y1, y0, y1, y2. And it will be stored at y plus I. Now you have obtained the x and y coordinates from the user, then you can use that to initialize this. So the points x and y should be pointers. So they are already pointers. So the first will be x comma y. Point initialize x comma y. And the second point will be x plus 1, y plus 1. Okay, they are pointers and it will return pointer. And this triangle initialize also contains pointer. So then this should work. And this should be x plus 2, y plus 2. Now the triangle is initialized. Then you can calculate the perimeter by calling this perimeter function. And I'll just say perimeter is long float this way. And for that one, you have to call the perimeter function. So we can call perimeter, and as the argument, you must pass the triangle structure as the argument. So what is the triangle structure? This initialized triangle structure, TRI1. Right, this is a long program, so we'll see whether there are any compilers or not. There are any 55. Here there is a alien. There is a spelling mistake. Again, many errors. 10. Okay, 44. I think here there should be a bracket. And okay. $51. Here in function definition, you don't use a comma here also. Okay. Uh, Point has no member name. Why? What was the its member name is Y. Oh. Okay, start point has no member name. Double. So we'll see what has happened here. So it has a point. It says it has no member name y, but it has a member name x and y. Here I have missed the semicolon. Now only one error. Struct a triangle. Is there a triangle? Maybe here. We have written maybe. The data type of triangle initialization, return type must be a pointer, and here, so this should be a pointer data type, that's right. So we have to be careful about the return type of this function. So I have declared it as a pointer, so this should be a pointer. In that case, here, yes, this is a pointer. So you have to pass the value here, so it will be value. Okay, so that is this program. So in for my PC, it is giving a warning that the function square root is not defined in math.h library, but I don't know why is that going to happen, because square root, this function is defined in math.h library. So in your case, you can check whether it is defined or not. So you can use, so this is the correct program. So I'll just remove that one to show you that this is correct. So in your case, you must include it because the correct one is here. In my machine, the math.h library, I think it is not included, or maybe it is not downloaded. So x0, you can enter value x1, x2, segmentation faults. Okay, you can try this program and at home and check what is going on. So there's no time to check it now. So this is how you work with structures and how to return the value of structures, and also how to use a structure as a pointer. So you can use a structure as a pointer. So it gave you errors when you are not correctly using it. So for example, here I have returned the structure as a pointer. In that case, in your main program also, you should return it as a pointer. And in that case, if your structure is a pointer, the most important idea is you have to use this operation to access its members. If it is a pointer, if it is not a pointer, you can use the dot operation like this one. So this tri1 is not a pointer, then you can use this one. Okay, so that is all about the C programming in this operating system program. I hope you have got a good understanding and experience from this one. So you can try out these exercises on your own at home. So I'll upload the video also to the LMS. Then you can try these things on your own and how to tackle with the compile errors and etc. Then you will get a good background to step into operating system programming. Right? So we'll wind up the session here, and we'll meet next week, and we'll be starting a new section, that is using input, outputs, and interacting with the operating system using high-level C programming. Right? We'll officially begin programming on operating system from next week. Right? So if you have any doubts regarding today's session, you can ask. Otherwise, we'll wind the session here. Right, so we'll wind up here. So we'll meet next week. Thank you.